called convolution integral. So when we are discussing Laplace transform and Fourier transform, I have repeatedly told you that convolution integral and modulation properties are more important and also repeatedly asked in university examination. It has a lot of application in not only in signal system, signal processing or communication. It has many application in control system, wireless system, etc., etc. So, and also it's very important to know what are the complexities in convolution integral, okay, and how it can be easily solved when we are taking transform of the given signal. That is the important story of today's lecture. Okay, now generally convolution of two uh, continuous time signal, convolution of two continuous time signal x of t and h of t is denoted by y of t is equal to x of t into convolution h of t, and this operator is actually called convolution operator. It is not simple multiplication operator, it's a separate operator, convolution operator. So y of t is equal to x of t convolution h of t. This can be represented using integration minus infinity plus infinity x of tau into h of t minus tau into d tau. So this equation, this integration, convolution integration formula I have given in previous lecture. So it actually what it represents is, so just consider a linear time invariant system. Consider a linear time invariant system. Now if it is system in, it require it consists of input and output signal. So now you just consider x of t is input and y of t is output, and now y of t is nothing but convolution of x of t, that is input and impulse response of the linear time invariant system. Impulse response is nothing but response of the system when input is del of t, that is h of t. So when you are giving x of t as input to the linear time invariant system, it will produce output y of t, which is convolution of input signal x of t and the impulse response of the system. Okay, y of t is equal to x of t convolution h of t. This is the theoretical or theoretical part of actual convolution integral. Now, what this Fourier transform and Laplace transform, or even we are going to study about Z transform, will do is this convolution operation. Generally, it's a tedious job. If you are taking Fourier transform or Z transform or Laplace transform, this convolution will become simple multiplication. And I am repeatedly telling you that convolution is very tedious job, and I have not given I have not taken convolution problem. Now I am going to talk about convolution problem. Then you will understand how it is tedious and how it can be easily solved by taking Fourier transform. Okay. Now before solving a problem related to convolution integral, I just want to give you a few properties of convolution integral. Convolution integral has the following properties. One is commutative, that is, you can take, for example, you can take x of t convolution h of t, then that is equal to h of t convolution x of t. If you are changing the place of the signal, then there is not really change in the convolution output. So x of t convolution h of t is equal to h of t into, h of t convolution x of t. Then it has a second property is associative property. Associative property says convolution of two signal, that is x of t convolution h1 of t, convolution of h2 of t is equal to, so you can directly convolve independently and take convolution, that is x of t you can take outside, okay, and then when you are taking convolution of h1 of t and h2 of t, after that you can even take convolution of x of t and the resultant one. These two are same. This is called associative property. And distributive property. Distributive property says x of t convolution h of t plus h1 of t plus h2 of t, then if you come across this kind of thing, so this is not there, this closing bracket is not there, so x of t convolution h of t plus h2 of t, then it can be determined by x of t convolution h1 of t plus x of t convolution h2 of t. So these are the three important properties of convolution integral. Okay, now we are going to solve a simple problem as far as this topic concerned, and we have even more complex problems also, but we are not going to discuss now today. I am going to discuss a simple problem, and I want to give a credit to the book name called Sham series. So the same problem is available in Sham series. I have mentioned this name, signal system, chapter 2.6. You can refer Sham series book, the same problem is available. Okay, now just a minute. Now I'll read the problem and we'll discuss the problem, and we will discuss about how to solve this problem. First thing is, evaluate y of t is equal to x of t convolution h of t, where x of t and h of t are shown in figure 2.6, that is the figure name given in the book A, by an analytical technique, and B by graphical method. You can solve this convolution problem in two different ways. One is analytical technique, another one is graphical technique. Analytical technique is nothing but is simply solving using integration function. Graphical technique, you have to use graph of the signal, and then we have to evaluate by multiplying two different graphs. First, we are going to use analytical technique to solve this problem. First, we express x of t and h of t in functional form. So we have two different functions. X of t. X of t is defined over 0 to 3, and the value of and the amplitude of the signal is 1. So x of t is defined over 0 to 3 and its value amplitude is 1. Similarly, h of t, we have h of t, this is defined over 0 to 2, the amplitude value is 1. Now we have to write this particular this signal in terms of mathematical expression. For example, if you are taking x of t, it is looking like a step signal, but step signal is defined over 0 to 3. It's simply I can say subtraction of two different signal. For example, if you are taking this expression, that is x of t is equal to u of t minus u of t minus 1. Here u of t is a step function, is defined over, I'll draw it, this is u of t, this is defined over 0 to t infinity, t is infinity. At the same time, u of t minus, this is u of t, I am going to draw u of t minus t. U of t minus 3 also a step signal, but the thing is, the step signal, that is the signal will start at t is equal to 3. Here the signal start at 0, here uh, when t is when u of t is u of t minus 3, the signal will start at t is equal to 3. Now when you are subtracting these two signal, I will get this signal. When I am subtracting these two signal minus this signal, I will get the first signal, that is x of t. Okay. Uh, Similarly, if you really want to generate h of t, you have to subtract you have to subtract u of t and u of t minus 2. That is the signal defined from t is equal to 2. You have to subtract this one and this one to generate h of t. So I have represented and represent these two in this equation, that is x of t can be mathematically written like u of t minus u of t minus 3, and h of t is written like u of t minus u of t minus 2. So I have given mathematical expression to x of t and h of t. So these two functions I have written in terms of step function. Now I am going to write integration formula, convolution integral formula, that is y of t is equal to x of t convolution h of t, and this can be expressed like integration over minus infinity to plus infinity x of tau into h of t minus tau. Now we are going to substitute x of t and h of t in this integral formula to evaluate the value or determine the value of this particular signal. Now I'm going to substitute the value of x of tau and h of tau. X of tau is nothing but u of tau minus u of tau minus 3. Tau is a dummy variable, so instead of t I have taken tau. You can even use different dummy variables also. So I am going to substitute x of tau. X of tau is equal to u of tau minus u of tau minus 3. Similarly, we are going to substitute h of t minus tau. H of t minus tau is u of t minus tau minus u of t minus tau minus 2. Now we are going to multiply these two functions, and I am going to decompose into 4 different parts. So when you are multiplying u of t and u of t minus 1, I will get this one. Then u of t into u of t minus tau minus 2, I will get this one. Similarly, that is a plus b into a minus b or something like that, multiplication of 2 different functions. So I will get 4 different function or 4 different integration. So we are going to integrate one by one to obtain the solution for this particular problem. Now, so this is the integration. We got it from the previous slide. So this one. Yes. So this is the convolution integral. We got it by multiplying 2 different functions. Okay. So we are going to separately integrate this function to produce result. First I am going to take the first integration. Here you must be very careful. So I am going to give some limits and how to place the step signal, and you must be very careful what I am telling, otherwise it's very difficult to understand. So I'll start only one thing, and the rest of them will do it later. Okay, maybe next class. Now first we are going to take u of tau and t of u of t minus tau. So this is equal to, okay, since these two are we are simply multiplying step function. When you are multiplying 2 different step function, the amplitude remain same because 1 into 1 is 1. There will not be any change in the amplitude. I am going to write like multiplication of u of tau and u of t minus tau is equal to 1, and we should know the duration. Okay, because first function is function of tau and second one is function of t minus tau. Here tau can take values from 0 to infinity. Here it is different because this is t minus tau. So this tau will take values from 0 to t. Hence it is represented like 0 is less than tau is less than t, and another function is t is greater than 0. Okay, so we have two different functions, one is tau as well as t. So t can take values from 0 to infinity, not even 0, greater than 0 to infinity, but tau can take values from 0 to t, 0 and t, that's it, because tau is lying in between 0 to t. This is the first interpretation. In similar way, we are going to write the equation. For other integral also. Here u of second one is u of tau and u of t minus 2 minus tau. Here also multiplication of two-step signal. Okay, here the tau, this tau is lying in between 0 to t minus tau because tau is equal to t minus 2, and this t is greater than 2. Okay, because t minus 2 is equal to 0, hence t is greater than 2. Similarly, next one, u of t minus 3 and u of t minus tau. So previous case you have only u of tau and u of tau, but here u of tau minus 3, hence tau is equal to 3. Because of that, the signal start from 3 to t, and t value is, when you are substituting tau here, you will get t is equal to 3. Hence t is greater than 3. Listen carefully. Here tau value is starting from 3 because tau minus 3 is equal to 0. When you are substituting tau minus 3 is equal to 0, you will get tau is equal to 3. In the second step function, when you are substituting tau is equal to when you are substituting tau is equal to minus 3, you will get t minus 3. Hence t is greater than 3. Likewise, the last function u of tau minus 3 into u of t minus 2 minus tau. So here already we have discussed u of tau minus 3. Here tau is in between 3 to listen, it's very important because here there is some delay in the independent variable t. Hence you cannot directly write up to t. So tau is equal to for the first function tau is equal to 3, but it will stop at the second function tau is equal to t minus 2. Okay, because here tau value is t minus 2. So that is t minus 2 minus tau is equal to 0. When you are substituting, you will get tau is equal to t minus 2. Okay, now we have to again concentrate on t, where the t is starting. Here you are going to substitute the value of tau here. Tau value is 3. So t minus 2 minus 3, you will get t is equal to, I'll write once again, t minus 2 minus 3. 3 is nothing but the value of tau that we have taken from the previous function, that is u of t tau minus 3. Here tau minus 3 is equal to 0, so tau is equal to 3. When I am substituting, I'll get t minus 5. So t minus 5 is equal to 0. From this we can say that t is greater than 5. Okay, because t, when you are equating 0, you will get t is equal to, the starting point is equal to 5, in such a way that we can we can write the upper and lower limit of tau and t. With this particular limitation, we can directly integrate the equation and find the result. For example, we have elaborately discussed about how to change the limit for each and every integration. We are going to substitute this value in the integration, and we are going to find the solution. So now we are going to take the first equation, that is integration over minus and plus into t u of tau into u of t minus tau into d tau. For this case, the limit is, for this case, ஒரு நிமிஷம், for this case the limit starting the tau value starting from 0 to t. Okay, so for 0 to t the integration value is 1. Okay, so for this case so all of you please wait for some time. Okay, so here you are going to for this case the integration is starting from 0 to t into d tau, because u of t value is 1. Okay, so 0 to t into dt minus, for second case the limit starting from 0 to t minus 1, the tau integration limit starting from 0 to t minus 2, so minus integration over 0 to t minus 1 d tau and u of t minus 2, because here you are going to substitute t value here, you will get t minus 2. So similarly, when you are substituting the value of the limit in this equation, you will get 4 different terms. By simply integrating this term, you will get this answer. Okay, so now we have to plot all these functions to obtain the final result. For example, you take the first term. It says it's a ramp function. It means when t increases, y of t will also increase. So this particular line represents t into u of t. Okay, this line represents t into u of t. The second function says t minus 2 into u of t minus 2. U of t minus 2 means the signal should start from 2. So this point, the signal should start from this point. The important thing is we have to the function t minus 2 is multiplied. T minus 2 is multiplied means when you are increasing the value, okay, when you are increasing the t value, the function will also increase. For example, when you are putting t is equal to 0, what will happen is the value is minus 2. So it is a simple decreasing function. Okay, and the slope is t minus 2. This is the function which will represent the second term. Similarly, t minus 3 into u of t minus 3, the third function is here, and fourth function t minus 5 into u of t minus 5. Okay, and this is the one. Okay, so you can ask me why it's this function of positive function, why you are drawing in negative side, because a minus is multiplied. Because of this minus sign, we have draw this signal in negative side. Okay, now we are going to add all these signal. So here we are going to subdivide the entire graph into small part. like I'm drawing vertical lines, okay, and then we are going to add all these things. For example, I'm going to take this 0 to 2. 0 to 2 I have only one function, okay, so there is no change in the function, so I have simply draw a straight line of 45 degree. When you are coming to the second duration, that is 2 to 3, what I will get is I have to add positive as well as negative, that is t, okay, this is actually t and t minus 2, okay, I have to add these two functions, this is t and here minus t plus 2. When we are adding these two functions I will get 0, okay, 0, but that is placed at 2, that is simply I can say t minus t plus 2, okay, so t will both will cancel and you will get only 2. That's why a horizontal line is represented. Similarly, you are going to add t and t minus 3, okay, t minus t plus 3, okay, you will get, what you will get, you will, the function will get decreased, and then once again we are going to add will increase. So simple way you can increase and decrease, this function will decrease and increase purely depends upon the value of c. Is a simple I'm saying simple convolution, but we need to do a lot of iterations and also a lot of assumptions to obtain the final solution. So as far as mathematical expression concerned, convolution of two different signals is very difficult. Because of this reason, no one is choose for convolution, and instead of convolution people will opt for multiplication, that it's very simple to take Fourier transform and multiply two signal, and once again you will take inverse Fourier transform. So this is one way of convolving, and I have written the final result here, and I think